Welcome everyone. This is Zahid Bashir. I am discussing today the online training session on SPSS 27. It is basically the 10th day training, dated 19th March 2024. It is wrongly stated as 8th day, but it is 10th day training. So myself, Zahid Bashir, I am a faculty member at Department of Commerce, University of Gujarat, and a PhD scholar at Delhi College of Commerce, University of Punjab. So, what are the contents for today's part and what we are going to discuss today? Most importantly, these are the contents that we have covered so far, like business, basic environment and layout, familiarity, data management, overview of the survey questionnaires and types, code book creation and data entry, missing value analysis, demographic summary and cross tabulation, and reliability analysis. So up till the seventh content, we have covered a lot. And today we will discuss how to compute your variables and how to estimate the descriptive analysis of these computed variables, which are known as composite variable. So today we will discuss the topic number 8 and 9, and tomorrow we will discuss the visualization using graph, and we will cover the visualization in 2 days. It means the half part of it will be covered tomorrow, and the remaining half part will be covered the day after tomorrow. And in the similar way, we will cover the remaining sessions day after day. So these are the topics for today's discussion, like variable computation, descriptive statistics of the composite variable, and interpretation. So after analyzing the reliability of variables, you need to compute your variables from your given set of indicators. So let's suppose that we are having the same data that I have shared with you previously from this example. That is the practice data set I have shared with you previously. So I am going to use the same data set for our analysis. In yesterday's session, I have taught here how to check the reliability of your indicators or reliability of your statements. So that is the first step before computing your variables. So in order to validate your scales, that you are going to use the right scales of your variables, you need to consider their reliability. If the scales are reliable, the next step is to compute your variables. So how to compute your variables? So first, let me show you the questionnaire. This was the questionnaire that I am focusing for your practice. So let's suppose I am going to compute the short duration training statements. So there are 6 statements: short duration training 1, short duration training 2, and so on up till short duration training 6. So I have collected data with short duration training with SDT1, SDT2, SDT3, SDT4, SDT5, and SDT6. And we have also confirmed the reliability of these statements yesterday. It was about 90% and so on, and it is greater than 70%. So now we need to compute a composite variable based on these 6 statements. So how can we do it? We need to go to transform, and here the first option is compute variable. You need to click on this. Now, for the variable that I would like to compute is SDT on the basis of 6 statements: SDT1, SDT2, SDT3, SDT4, SDT5, and SDT6. So on the basis of these 6 statements, I am going to compute a variable which name is SDT. So how can I compute it? I need to go to the numeric expression. Then I go to here, the function group. Here you will find the statistical option as a function group. You need to click on it. and you need to click on mean, double click on mean, and it will show you the formula, the mean option formula, and you will see uh, two question mark here. You just need to remove the question mark and you need to retain your bracket. So within the bracket, you need to double click SDT1 because you are going to calculate your composite variable SDT on the basis of these six statements. So first you need to do is double click SDT1 and it will appear here. Now you need to put comma after your first option. You can press it from your keyboard, comma. Then you need to double click STT2, then comma. Then you need to click STT3, double click, and it will appear one by one, and you need to please place the comma after each indicator. So double click STT4, comma, double click STT5, comma, and double click STT6. After the last SDT, you don't need to put any comma here. You just need to click OK button from here, and you will find the command is executed, that you have compute your variable and it is executed. In order to verify that the variable is computed, you just need to go to your data set and you need to see the data view here. You can scroll horizontally from left to right and you will see a variable named STT. Now it is computed here and you will see the values here as a part of the computation of your composite variable. In the similar way, you need to compute the other variables too. So apply the same procedure, go to the transform, go to the compute variable. As we have calculated SDT composite variable, now next is LDT, which is long duration training. If we see in the questionnaire, we have long duration training. So on the basis of these statement, long duration training variable will be computed. That is LDT. So what I need to do, I need to go to my variable computation phase. I need to put here LDT. I need to erase its statement from here because I need to put here the LDT statement. So in the same way, mean within bracket should be blank and go to LDT1, double click, comma, double click, comma, double click, comma, double click, comma, and double click. After putting all the factors related to LDT, go to the OK button and it will execute your next composite variable. So you can verify it from here. Yes, right here. The LDT variable is computed like this. So variable along with its values are appearing over here. So what I need to do next, I need to uh, perform the computation of next variable. For example, that is ES. So what is basically the ES is that ES is the effective scheduling. And these four statements are related to ES. So we need to compute the variable ES here. So how can we compute it? We go to here, go to transform compute variable. You just need to rephrase it, put the variable name ES, and you need to remove their indicators because they are related to the LDT. So we need ES1 here, comma, ES2, comma, ES3, comma, ES4. So this is how we can compute the different variables. So this is the third one. You can verify from here. It is appeared here. So as you are computing different variables, these are going to appear over here. So in the same way, I am going to compute another variable, which is OS, that is optimized scheduling. If I see from my questionnaire, it is optimized scheduling. So it is based on these four statements. So I need to compute it in the similar way. I go to transform, go to compute. I place here OS, right here OS, and you need to remove the indicators of the previous composite variable. Double click OS1, double click OS2, comma, double click OS3, and comma, double click OS4. Now click on OK, and you will find the fourth one like this: 1, 2, 3, and 4. So we have calculated four variables here, or four constructs here. So next thing that you can do is you can compute all your variable in the similar format. So I am going to compute the other variables too, like fs, fs, and I need to put here their statement or indicators like fs1, comma, fs2, comma, fs3, comma, fs4, comma. Now the next one is ps actually. I don't need to put it. Just click OK, and it will compute the similar way the next variable. So how many are remaining? We are having only one variable remaining, that is PS base, that is project scheduling. In this case, first I need to uh, correct their measurement from here. I need to go to the variable because previously I might not have saved their measurement, so I need to rectify their measurement from here like this. The composite variable should have the similar measurement. Always remember, if they are nominal base, they all should be nominal base. If they are ordinal base, they all should be no, ordinal base. And if they are, basically, I am discussing about the factors. The factors should have same measurement. So, if I am measuring PS, all the factor of PS should have same measures of scale. So what I need to do, I go to the transform compute variable. Now I am going to measure PS. So here I will put all the factors of PS here, like here PS1, comma, PS2, comma, PS3, PS4, PS5, PS6, PS7, PS8, PS9, PS10, PS11, comma, PS12, comma, PS13, comma, PS14, comma, PS15, comma, and PS16. Click OK, and you will find a variable of PS here. So these are the computed composite variable like SDT, LDT, ES, OS, FS, ES. So what we have done, we have so far computed our variables. The next step is the descriptive statistic of composite variable. How can we uh, estimate the descriptive statistic of composite variable, and how we can interpret the descriptive statistic? So the next thing that you need to do is you go to analyze, go to the descriptive statistics. Uh, Here you will find the descriptives option here. You can click it, and you can select the composite variable from here, put them one by one, the composite only. These are the composite variable that you have computed right now. So put them into the variable side, go to the options and see whatever you would like to see as a as a descriptive statistic. If you would like to see the kurtosis and skewness, check them. The minimum requirement in order to see in descriptive statistic is the mean, standard deviation, minimum, and maximum. But sometimes some of the researchers also prefer to use kurtosis and skewness as a part of the descriptive statistics. So you can check them and click continue. You may have other options, but these options are not required here for our purpose. So you just need to check these minimum options from here. So what you need to do, you need to click on OK, and it will generate the descriptive statistics of your analysis. So first I would like to discuss from here what these statistics mean and what they actually means here. So if you see the n statistic column, n statistic basically indicates the number of observation or your sample size in your data set. So there are 456 responses in your data set. So you can verify from here. If you go to the data view, you see here the case numbers. So if you drag down your scroll button, you will see that your data is available for 456 respondents. So it is verified from here. There are 456 respondents in your study. Then minimum statistic and maximum statistic. If you find the minimum value which is available in your data set is 1.17 for SDT and maximum value 5 in case of SDT. In the similar way, the minimum value of LDT is 1.20 and maximum is 4.80. The minimum value of ES is 1.25 and maximum is 5. The minimum value of OS 1.25 and maximum is 5. The minimum value of Fs is 1.25 and maximum is 4.75. The minimum value of Ts is 1.31 and maximum is 4.69. So what these values actually indicate, if you go to the questionnaire, it was the questionnaire for your study. I have indicated here a scale: strongly disagree, disagree, neutral, agree, and strongly agree. These scales indicates the number. If someone select this statement and he has indicated strongly disagree, or he basically strongly disagree with this statement, he will select this option and it indicates 1. If someone indicated simple disagreement with the statement, he will select disagreed column. It means it will select 2. So I would like to show you more here. Like for example, you need to understand these numbers because these would help you in analyzing and interpreting your result. So scale interpretations. So always try to understand the numbers. One means here in terms of scale, one means strongly disagree. Two means simply agree, simply disagree. Sometimes you strongly disagree, sometimes you simply agree or disagree. Three is neutral. Neutral means you are neither agree, you are nor disagree. Fourth means agree, simple agreement. And the fifth is strongly agree. So if a person is not agree with your statement, he will select 2. If a person is agree with your statement, he will select 4. If a person strongly decline your statement, he will select 1. And if a person strongly favors your statement, he will select strongly agree. But if he does not know whether he is agree or disagree, he will select 3. So, in this case, in our analysis procedure, the minimum numbers are mostly related to disagreement. So, we can say that the minimum numbers are indicating strongly disagree, and the maximum number, if you see here, are mostly, if we round the figure, they all are after rounding are 5, 4.8, 5, 5. They all are 5, means they are indicating strong agreement. This is the average value of your responses, and they will indicate that what is the real case. So most of the people are in between 3 and 4. Either they becomes neutral or they become agree. If your average value is greater than 4, at least 4 or greater than 4, it means most of the people are agreeing with your statement. So this is how you can interpret these values. So you need to understand that these mean values are the actual indication of your responses. That if short-term duration training is concerned, most of the people are simply either agree or neutral with your statement. If the long duration training is concerned, most of the people are either neutral or agree with your statement. It means they are not giving any negative indication. Always remember that neutral means zero. It is neither agree nor disagree. If a person is disagree, it is giving negative indication on your statement. So it is a negative indication. It also a negative indication, or you can say highly negative indication about statement. In the similar way, agree is a positive statement, and strongly agree is highly positive statement. So you need to understand the logic behind these numbers. So if a person indicates or select 4, he is giving a positive indication. So, what we have learned here, we have learned that most of the people are giving the positive indication towards all these constructs. The next thing is standard deviation. Standard deviation basically indicates how much value uh, deviates from its mean. So, in interpretation, this value is not required, but you need to understand the logic behind standard deviation. So, your mean would be plus minus with this value. It means it would happen that this value, if we add this value in this 3.4 to 38, it becomes 4 point something. So it will go to this side, this agreement side, or strong agreement side, if it is added. In the same way, if we subtract this amount from 3.4 to 38, it will ultimately go to this side, this negative side. So what we have basically confirmed from here, we have confirmed that this standard deviation may change the interpretation of your mean values, that most of the people are on the positive side, but there are chances either they becomes the strong positive or simple negative. In the same way, if you consider the skewness and kurtosis, they are basically the indication of normality of your data, whether your data is normal or not. So, what is the criteria of considering whether our data is normal or not, whether normality is concerned, or whether your data estimation is valid for your estimation or not. Let's suppose if we consider skewness, your value should be 0 or close to 0, which indicates normality of your data. Normality is basically required for the validity of your estimates. Your estimates will be considered valid, will be considered efficient if your normality is confirmed from your estimation. So your skewness should be zero or it should be close to zero. Then we may say that our estimations are correct, our estimations are normal, our estimations are valid. In the similar way, the value of kurtosis should be plus minus 3, like I would like to show you the symbols, the plus minus 3, or close to plus minus 3. If the value is different from plus minus 3, higher than 3, it would not be considered normal. Normality of your data. So this is the criteria to consider whether your data is normal or not. So if we see here, the statistic value, you need to see the statistic value. These are 0.605, 0.579, 0.720, 0.504, 0.731, 0.723. So these are close to zero. These are not greater than zero. These are close to zero. So when the value is actually zero or close to zero, it indicates the normality of your data. The second criteria is kurtosis. Your value should be in between plus minus 3. So if we see here, your values are less than 3, 1.231. It is between the range of 3 plus minus 3. If this number is greater than 3, let's suppose 4.231, let's suppose 5.043 or 5.971, it goes beyond this level. So always remember that your data should be within this range, either within the plus 3 or within the minus 3. So it will indicate the normality of your data. So if we would see here, these values are also indicating the normality of data. So what we concluded here, we have concluded here that these values are reliable, these values are valid, and these values can give us the valid estimations that we further analyze. So let's take this table here in order to make interpretations. So I need to adjust this table. I need to consider a lot of formatting here as to make it more attractive and more acceptable in terms of research community so that you can understand its purpose. For example, this one is related with skewness. We don't need to worry about the standard error value. We don't need it at all. We just need the values of statistics. So if you want to remove the standard error, you can remove it. You don't need to show your standard error values. But if you want to retain it, there is no objection about these values. So how can we interpret them? Let's suppose this is the table 1, descriptive statistic, and if I would like to show it in APA style, which is the recommended style for your thesis or for your research papers. So how can I do it? I just need to click on it. I go to the home option, select the no border from here like this. You also observe that there are some color highlighting over here. So what I need to do, I go to the highlighter, I select no color, uh, again select it, select no color, but it is not indicating anything. So what I need to do, I need to select this option, go to the no color, but it is not indicating anything. It means it is filled color. So I go to the filler that is shading. I go to no color from here. Yes, it works. So you can also unshade this. You go to the shade area, select no color like this. Now it is unshaded. You can select the font color as a black. You can delete this number because it is not actually required. You can go here, delete the row like this. Now you can adjust this table again. You can select the all borders for formatting these tables like this. You can consider here the short form like minimum. You can make them centrally aligned. In the similar way, you can select here maximum as a max like this. In the same way, you can select minimum with the same wording. You can select standard deviation. The short form of standard deviation is STDV. You can use it. Then, in the same way, you can use skewness statistics as well as you can use the kurtosis statistics like this. So, if you would like to remove the table, the standard error from here, you can simply remove it because it is not required in case of interpretation of the table. You can put your skewness from here to here like this. You can put your kurtosis from here to here like this, and you can paste your table from here right here. Now this area is basically becomes irrelevant. If I would select it, I can remove it from here. Delete column. Oh, it is not considering it. The next thing that I can do from here, I go to the insert, select chart table. I can make separation from here. You need to connect this area like this. Then you just need to select this area. Now it is separate now. Now you can delete the column like this. Now it is much better now. Delete rows and you can put it here. You simply need to select it like this and you can put it here like this. All right. So if you want to delete this area, how can we do it? We just need to connect this row from here to make it separate area and make it again. Go to this, undraw it and select this row. Go to delete button, delete the row. Now it is much better now. Now you can make it much comfortable like this. So one thing while doing interpretation, always remember that you need to tell What these means? These are the factors or constructs. So you need to put here the word construct here because they are called the constructs. You can also write here the name measure, measure, scales, constructs, or factors. So what does SDT mean? SDT here means the short duration film. What is LDT mean? LDT means here long duration film. What is ES means here? That is, if we see in the questionnaire, it means effective scheduling. So I need to write here effective scheduling. Next is OS, that is optimize scheduling. Next is FS, that is flexible scheduling. And the last one is PS, that is project success. So the first thing you need to tell the audience that what these factors actually are. The next thing you interpret. According to the table one, the mean values or the average values of all the constructs are mostly either indicating the neutral or greater than neutral values. It means that most of the respondents agree on the statements provided for the constructs in the question. So I have told you that 3 means neutral, but there are some values which are greater than 3. So it means most of the people are basically going towards the agreement because they are coming out of 3. It means between 3 and 4, there are mostly most of the people are agree with the statement. The second thing, uh, the most of the people are agree on the statements. The second thing is that the the skewness and kurtosis indicates normality of the data. So this is how you can interpret your descriptive statistic table. As the time has ended, if you have any question, you can ask. Yes, Miss Hina or Rabia, do you have any question?
No, sir.
All right, I think it is understood. So let's meet tomorrow with next topic. So stay safe.
सर एक्सक्यूज मी सर आई हैव वन क्वेश्चन
Okay.
सर ये जरूरी है कि स्क्यूनेस और कर्टोसिस दोनों